So today, 12, 12, 18. So what we want to do today is we want to graph the other graphs, the co-functions. We call them the co-functions. We're going to graph the co-functions. So we need to start with tangent, okay? So start right with our pi halves, our pi, 3 pi halves,
I have a question.
and our 2 pi. Yeah.
Will we ever have to remember all this?
No, I will always let you use your notes, okay? But you're going to have the notes, because I'll have the circle.
What
I'm
about
not
like in other math classes?
pre-calc, yeah. If you take pre-calc, you're going to need to know this. Okay, now, here we go. So, a couple of things. Let's put our 1 here and our negative 1, okay? So, let's go through the tangent values. Let's start, first of all, with 0. So, the tangent of 0 is 0, right? Okay. I'm going to go to pi force because it helps us. I'm going to go to pi force right here. So pi force is one of my angles.
Okay.
If I go to pi force in my unit circle, the tangent value is 1, right? So I'll put a point at pi force and 1. Now if I go to pi halves, something odd happens. The pi halves, if it's the y divided by the x, then it's 1 divided by 0. You can't divide by 0. So that's why I have this symbol here. It's undefined, and when we divide by 0, we put an asymptote. Remember that with fractions? So I'm going to put an asymptote at pi halves. Okay, now I'm actually going to go backwards, and I'm going to go into my negative angles to get the rest. So I'm going to go to a negative pi force, and from my unit circle, you guys watching? Negative pi force is actually here. See the distance? Negative pi force is actually here. And so because if pi force is here, the negative pi force will be here, and my tangent value is negative 1. See that? I'm going to do it again. Pi force is here, so negative pi force is here. So my tangent value is negative 1. Okay, so I'm going to put a point at negative 1. And then if I continue this, negative pi halves is here. Negative pi halves again is negative 1 divided by 0, but you can't divide by 0, so you have an asymptote here at negative pi halves. So I'll put my asymptote in. So, yeah. I'll do it real quick. Okay, so at negative pi halves, which is here. Okay, watch. Pi halves, negative pi halves, right?
I lost the negative pi force one.
Okay, you ready? Pause pi force.
Yep, I got that part.
Negative pi force.
Go further ahead.
Here's my tangent value here, negative 1. So I've got at, yeah,
at negative 4.
pi force, negative 1 and negative 6. Okay, and then finally I've got the asymptote at negative pi halves. Okay, so then the graph looks like this. And it does curve. Okay, that's my tangent curve. Now, it keeps going and going and going. That is one tangent curve, okay? So let's stop there for just a minute and think about the period. Now, the period is how wide this graph is. So how wide is this graph? How wide is this graph?
2.
You go from pi halves, from negative pi halves to pi halves. The period's pi. So the period is pi, okay? It doesn't really have an amplitude, but the number here corresponds to its height at pi force, okay? If this number were 2, this value would be up here at 2. If this number 3, it'd just stretch it longer, okay? Does that make sense? Okay, yeah, Cody?
Would the amplitude be infinite because it goes up
Yeah.
forever?
I agree with you. So it doesn't really have an amplitude, but this number here will tell you where to graph this point at pi force.
Does the curve have a name?
Yeah, this is a tangent curve.
Well, yeah, but like when it starts to curve, like you have the 2 points, and does that section have a name?
Some people call it an amplitude. That's what they'll call it, right? But I agree with you. It's not really an amplitude because it goes up forever, okay? All right, let's take a look then. It does continue to repeat itself, so it would also be here, and the graph would go through pi, 7 pi force, 5 pi force, and it just keeps going and going and going. But one curve is just a single tangent curve, but the curve goes on and on and on. Kind of like a heart rate monitor. Looks a little bit like a heart rate monitor, right? And we could graph another one if we wanted to. It keeps going and keeps going. Katie said no, but I'll put another one in there anyway, Katie. Just because I want to, right? So, and it keeps going and going and going. But one curve, one single tangent curve is this one here. Period of pi. Okay, thumbs up. Now the cotangent is just the opposite tangent. And as we graph the cotangent, you're going to see why it's the opposite tangent. Okay, slide it up. So, let's do the cotangent. Let's put our pi halves. Our pi, our 3 pi halves, our 2 pi, our negative pi halves. I'm also going to put in my pi fourths. Okay? And I'm going to put in a 3 pi fourths. Okay? Now, tangent is the opposite of cotangent. Okay? So if I look at the board, tangent's the y of the x, cotangent's the x over the y, right? So let's go through this real quick. Instead of 0, this one's going to be 1 divided by 0. So you divide by 0 here. You divide by 0 at 0. So we're going to have an asymptote at 0 for cotangent. So we're going to put an asymptote at 0. Okay? At pi fourths, you got a tangent value of 1, but 1 over 1, because of cotangent, 1 over 1 is still 1, right? You agree with that? So I'm going to put a value at pi fourths at 1. At pi halves, you're going to have 0 over 1, x over y. But 0 over 1 is 0. Okay, 0 over 1 is 0, so for cotangent, at pi halves, we'll have a value at 0. We're going to go to 3 pi fourths. For tangent, it's negative 1, but cotangent's 1 over that. So 1 over negative 1 is negative 1. So for cotangent, at 3 pi fourths, we're going to have a value at negative 1.
I'm so confused how we do this.
Okay, check it out. Okay, so Ben, let me write something up here that's going to help us. Okay, let me write that cotangent is the same thing as 1 over tangent. All right, you okay with that?
Yeah.
So let's just go to this value right here. What's 1 over 1?
1.
Good. So I've got a point at 1. Okay, you ready, Ben?
And then
What's
we go
1 over
pi
negative?
half.
What's negative? What's 1 over negative 1? What's 1 over negative 1?
Negative 1.
Right, and so I have a value here at negative 1, okay? So cotangent is just 1 over that value, right? So it's 1 over 0, undefined. How about pi? What's 1 over 0? Undefined. So we'd have an asymptote there at pi. Does that make sense? So what does the cotangent graph look like? Looks like this. And it is kind of the opposite of tangent. Okay, so it looks like that. So what's the period? It's pi.
Yep.
Period's pi. That's how wide this graph is. Cody's right. There's not really an amplitude because it goes forever up, but the number in front of here, they'll call as an amplitude. They'll say it's an amplitude. And it really is the value here at 1, okay?
Is the period always pi?
It's always pi for tangent and cotangent. Always. Okay? Unless we change it, we can change it by putting a number inside with the x, okay? Okay, turn the page. Okay, turn the page. Okay. So, cosecant. So to do cosecant is the same thing as 1 over sine of x, okay? That's what cosecant is, 1 over sine. What we want to do first is we need to graph y equals sine of x. You have to graph sine to get cosecant, okay? You have to. So what does sine look like? Well, let's put down our pi halves. Let's put down our pi, our 3 pi halves. We'll put down our 2 pi, and negative pi halves, okay? Put our 1 and our negative 1. So sine looks something like this. We've seen sine before. I'm going to put sine in real lightly because this is not our answer. Okay, there's sine. And we've done sine before, okay? Now, cosecant has asymptotes. Cosecant has asymptotes, and I'll show you why. So, Cosecant's 1 over sine. Okay, everybody watching? Because it really makes sense. It's 1 over sine. Right here at 0, sine is 0. Right here at pi, sine is 0. Right here at 2 pi, sine is 0. So right here, for cosecant, we would divide by 0, so we'd have to have an asymptote there. Right here at pi, sine is 0. So if we have 1 over that, we'd be dividing by 0 right here at pi. So we'd have an asymptote. So every place that sine has a value of 0, we would divide by 0. Therefore, we would have an asymptote. Okay? Make sense?
Yes.
Can't divide by 0. Now, when sine gets small, cosecant gets big because they're the opposites, the reciprocal. So the graph looks like this. As sine gets smaller and smaller and smaller, cosecant gets bigger and bigger and bigger. So cosecant looks like, and it touches right there, cosecant graph looks like this. And it looks like, it looks like a parabola, doesn't it? It's very similar to a parabola, but it's a slightly different shape. That's it. That is, these two purple loops together make a cosecant curve, all right? Both of them together. So the period of this is,
Cosecant for.
you know, you and Sasha, she asked the exact same thing. I Googled it, and believe it or not, we could not find a single application. Then I went to Massey, and Massey said, I don't know a single application either, okay? Yeah. So and then he said, well, there's some calculus problems with cosecant. I go, yeah, I understand. I go, but what's the application? He goes, I don't know any. He goes, but in calculus we'll use it. I go, great, I get it, but where's the application? He goes, so I looked it up, and there was a couple of them that said possibly in engineering. I'm like, I don't know. And there was one Google that said, I asked my college math teacher, and she said, I don't know any applications. So there you go. So anyway, let's do cosecant.
So why do we?
So Cody, let's do secant. So secant's the same thing as 1 over cosine. So first, let's graph y equals cosine of x. Okay, so cosine, I'm going to go pi halves, pi, 3 pi halves, 2 pi. You can use the tangent though, Cody. Think about a heart rate monitor. You know the heart rate? Tangent looks like a heart rate, and you can use tangent to illustrate a heart rate. You've seen the heart rate, right?
Yes,
Okay?
I have one.
Okay, there you go. You have a heart rate. I'm glad to hear that. So cosine looks like this, right? Cosine looks like this, you guys. All right, do your 5 points. Here's cosine. And I'm going to stretch cosine down a little bit further, right? Okay. Now, let's put in first, I'll let you catch up, the asymptotes. I know it has asymptotes because I will have to divide by 0 here. I'll divide by 0 here because that's where cosine 0. And I'll have an asymptote here because that's where cosine 0. Where cosine is 0, we would divide by 0, so you'd have an asymptote. So I'll have an asymptote here, here, and here. So I'm going to draw them in. Asymptote of negative pi halves.
Dude, you kind of lost me on the part where we have to do math to figure this out. Like, I kind of understood when we were just drawing waves, but now I'm confused.
Let me finish and I'll come back to you, okay? So, I have my asymptotes because this is where cosine is 0. That's where I divide by 0. Now, where cosine gets small, secant gets big. So it's the exact same shape, just in a different spot. It looks like this, touches here, and here. So the two graphs are very similar in shape. The only difference is where they start, right? It's the only difference. So what's the period? 2 pi. It kind of has an amplitude. You got to be careful because the amplitude really comes from the sine or the cosine, okay? All right.
So
Can
it's
I
just
have
the
that?
same, but this is just like cosecant, where